The challenge is to respond in the most efficient manner to the largest impending physical event in the history of civilization, in the form of the start of the next ice age, with the Sun going inactive sometime in the 2050s time frame. The challenge is so great that it will determine the future existence of all the northern nations on Earth, like Canada, Russia, most nations of Europe, some parts of Asia, and to a large measure the USA. The challenge of living in a world with an inactive sun for long periods, with 70% less energy being radiated by it, is so enormous and far-reaching in its consequences that it is hard to accept as our potential future in the near term, even while volumes of evidence stand in support of it. It has long been recognized that enormous ice ages have occurred in the past, with ice sheets more than 10,000 feet deep accumulating across the northern continents. But for the lack of any real plausible theory for the cause for such events, with the Milankovitch cycles theory discredited, the subject of the ice ages has been largely pushed into the background as an academic concern that is pertaining to distant future times instead of to the immediate present with enormous global consequences. The world's institutions of science have a critical role to play, therefore, in the resulting arena of critical superlatives. By definition, science is focused on discovering what is real, especially the aspects that are invisible to the senses, but are discernible in the mind by their effects. Unfortunately, the world of science is not that simple. In exploring the unknown, numerous potential avenues are typically pursued with hypotheses that often fall by the wayside as invalid. In addition, the orientation of science is all too often redirected in the service of political objectives, since politics provide the funding, which makes the discovery of truth even more difficult, especially at the leading edge, where conflicting interests and numerous conflicting ideologies converge. The Ice Age challenge is presently emerging at the center of the self-conflicting landscape of opinions, doctrines, and guided objectives. It has been put on the map once again as the result of some critical scientific discoveries, which by their nature render the dawning Ice Age challenge a momentous science challenge. The challenge is momentous because of the enormous consequences involved. The Ice Age challenge is a science challenge of the highest order because the potential consequences for humanity and civilization, if the challenge is not met, pale the worst that has been experienced in known history into insignificance. The great challenge has become immediate in recent years by a number of leading-edge discoveries of universal physical principles, which, once they are more fully understood, provide a new basis for solutions to a wide range of difficult problems that have muddied the water in a number of scientific disciplines. Many of the conflicts at the leading edge of science, especially in areas pertaining to the Ice Age challenge, have their roots in a single controversy. The controversy is whether cosmic space is pervaded by streams of electrically charged particles called plasma that link and power all galaxies in the universe and their stars and determine their interactions, or whether the universe is a sea of isolated, self-powered entities interacting loosely with no greater force than the force of gravity. This science controversy has deep roots and remains strong, even while ever more evidence is becoming recognized in support of the plasma universe concept. The problem with interstellar plasma is that its presence is invisible because of the small size of its particles that are 100,000 times smaller than the smallest atom. Plasma can only be seen by its effects on the atoms in space, when the plasma current is strong, and by the dynamic effects of the electric force that becomes visible by the often string-like alignment of the galaxies and planets. While the controversy over the existence of plasma in space appears to be purely academic in nature, in real terms, the opposite is true, because the future existence of humanity depends potentially on how this controversy is resolved. This is so because the recognition of the nature of our Sun is tied up in this controversy, in which the Ice Age challenge is located, that thereby has become the greatest challenge in science. The future existence of us all in the near term will be determined by how the great science challenge will be resolved and be responded to, and by whom, and if indeed it will be responded to at all. As I hinted at earlier, some parts of the science challenge are not new. One of the deep historic threads leads to the Swedish electrical engineer, plasma physicist, and winner of the 1917 Nobel Prize in Physics, Hannes Alfvén, who became famous for his work in plasma physics and for his work in the related subject of magnetohydrodynamics. Hannes Alfvén also became famous for his work in exploring the dynamics of plasma in space as an organizing force for the functioning of galaxies. Alfvén's breakthrough work was quickly eclipsed in his time and pushed into the background by the Big Bang creation theory of the universe, which had been strongly promoted at that time as a counter-ideology that is based on the assumption that plasma in space does not exist as a causative or organizing force. However, when one puts the omitted plasma back into the concepts regarding the nature of the universe, the fabric of the Big Bang creation theory becomes suddenly very thin and full of holes in the light of the resulting evidence. Researchers at the Los Alamos National Laboratory in the USA go into the opposite direction of the Big Bang creation theory. Researchers at the laboratory came to the recognition that 99.999% of the mass of the universe exists in plasma form, primarily in the form of electrons and protons that carry an electric charge and pervade all space, free-flowing, which by their electric potential become self-organized into vast electric plasma streams as the main organizing force in the universe in intergalactic space, some extending across billions of light years. Extensive experiments in high-energy physics provide visible evidence in the form of unique shapes of geometry, which indicate that controlling cosmic forces of similar geometry are electric in nature, for which numerous forms of similar geometry are evident in space, though much larger in scale. The researcher Antonin Parrott also discovered evidence in archetypal drawings from widely dispersed regions of the world that basically reflect the same plasma flow geometry. He suggests that large plasma flow structures would likely have once been visible in ancient skies, probably during the electrically hot times of the interglacial maximum period. Large-scale effects of cosmic electric actions between stars and planets have been discovered by researchers all over the world, with a flood of evidence being presented that we live in an electric universe. Many of the research findings are published in the extensive archives of the Thunderbolts Project. Most of the project's research papers are focused on large-scale historic electric astrophysical events, such as the forming of the Grand Canyon in Arizona, or of the gigantic canyon of Valles Marineris on Mars. The Sun, however, is rarely included as an electric astrophysical phenomenon. However, it is here where the critical consequences for our time of electroastrophysics is located. The inclusion of the Sun into the sphere of the electric universe takes the weight of science exploration out of the purely academic realm into the practical realm of down-to-earth living and frontline politics, where the consequences weigh in enormously if the science challenge is not met and the potential consequences are not prepared for. Researchers at the Los Alamos National Laboratory to keep the Sun out of sight as an electric plasma object, possibly for political reasons. Nevertheless, the work accomplished there at the labs has opened the door to further breakthroughs by other researchers. The plasma researcher David LaPointe took the critical step of putting the Sun back into the electric universe as an electric component. He brought the electric Sun concept back into view, which, from the time of the eclipse of Alvin, had been kept largely out of the sphere of serious science explorations. David LaPointe utilized partially static experiments to explore the operating principle of the unique magnetic geometry observed in high-powered dynamic experiments. He termed the operating dynamic fields the primal fields. His exploration work is important, as it provides a firm foundation for the long-standing theory of the plasma Sun, which puts the theory back onto the map, but with a twist. The old theory now became relevant again with reflections of the discovered principles becoming visible throughout the universe. Since plasma flows can be seen in space by their effect on atomic gases in areas of high-density plasma streams, the operating principles that have been explored in laboratory experiments are suddenly being recognized in space, often clearly visible, even while plasma itself is too minuscule in size to be directly observable. LaPointe's work is also important in another way. His experiments showed that a critical minimal plasma density is required for the primal fields to function. It is also known from basic plasma physics that in the real universe, where the magnetic fields themselves are dynamically created by the flowing movement of electrically charged plasma particles, that the resulting geometry in free-flowing plasma, which is forged by the Lorentz force and its pinch effects, depends on a certain density of the plasma in motion. This means that two minimal thresholds are involved that must be superseded for the system to function, below which the primal fields become inactive. This means, for the case of the Sun, that the Sun will become inactive when the plasma supply streams diminish below the system's threshold point. And this is precisely what stands before us in the near future. The current rate of diminishment of the solar activity, which was first measured by NASA's Ulysses spacecraft between 1998 and 2008, which is still accelerating, suggests that the minimal threshold for the Sun going inactive may be crossed in the 2050s time frame. The more one explores the electric dynamics of solar physics, the more evidence comes to light that the long-held theory of the Sun being an internally heated gas sphere that is deemed to be powered by a nuclear fusion process occurring at its core is wrong. The evidence instead suggests that the Sun is essentially nothing more than a large plasma sphere with nuclear fusion processes occurring on its surface. While the difference between the two models appear to be purely academic in nature, the opposite is actually the case. This is so because the plasma model of the Sun, which all available evidence points to, renders our Sun as a variable star that is vulnerable to changing supply conditions, meaning that the Sun can go inactive for long periods. When the minimal conditions are not met, the surface nuclear fusion reactions stop. Then the Sun will radiate only its stored up residual energy. It becomes darker then and weaker, whereby ice ages occur. The view we get by looking through the sunspots at what lays below the active shiny surface gives us an indication of what we can expect the entire Sun to be like in its inactive state. The vulnerability of the Sun to the presently diminishing plasma density conditions appears to be so critical to human living that it becomes imperative for our very existence on this planet that the plasma Sun model becomes understood as much as this is possible and be acknowledged as the most critical factor in modern civilization until absolute conclusions can be reached, if this is indeed possible. Nothing is more critical in modern civilization than our understanding of the plasma Sun model, because from the moment on when the primal fields collapse and the Sun goes inactive, the Earth will receive potentially up to 70% less radiated energy from the Sun, which emits from this point on only stored up energy, some nuclear fission decay energy, and perhaps also some mild forms of energy from lesser plasma interaction effects. It is obvious that an enormous reduction in solar energy input on Earth will result from the Sun going inactive, which will disable agriculture almost overnight above the 40-degree latitudes. Agriculture might remain possible only across the narrow band between the tropics of Capricorn and Cancer, centered on the equator, afloat on the sea between the hurricane zone for the lack of sufficient land near the equator. All of the northern countries above the 40 degrees latitude, due to the curvature of the surface of the Earth in the higher latitudes, will quickly become uninhabitable as the Ice Age begins rapidly under an inactive sun. In order for the affected nations to relocate themselves, 6,000 new cities will need to be built in the narrow band that remains livable on Earth. But will we do it? The evidence for what would need to be done affects many areas of science. I have recently produced a video study as a summary overview that presents 50 items of evidence related to the dynamics by which the Sun could go inactive potentially in the 2050s time frame. The summary is amazingly substantial, though it lacks the details that required a number of underlying exploration videos to present. Here, the science challenge begins. The science challenge is not a technological challenge for building the floating cities and agricultural modules. As large as these infrastructures are required to be, the physical task can be easily accomplished with fully automated nuclear-powered, high-temperature industrial processes. The technology exists. The materials exist, and the energy resources exist likewise. No science revolution is needed to implement what we already have at hand to be applied. The great science revolution is needed to inspire us to get the necessary steps of building started. While it is widely acknowledged that the world's food supply is rooted almost exclusively in agriculture, in one form or another, it is rarely acknowledged that more than 90% of humanity would die of starvation if our existing food infrastructure became disabled and no replacement agriculture had been built in protected regions to continue the food supply. The challenge to science is to get society off the easy chair and get the spade into the ground, so to speak. In comparison with the task of getting the world mobilized, the actual building of 20,000 kilometers of floating bridges and millions of acres of floating modules for agriculture and cities and so forth is easy. To judge by the current rate of weakening in the solar system, it appears that we have enough time left to have the necessary construction tasks completed before the Sun goes inactive, which may occur in the 2050s. But will we do the work that needs to be done? Will we even consider it? Most likely we will do nothing and commit thereby our children to an agonizing death. The answer that we will give to ourselves in this regard will be determined by our success in overcoming the science barriers that stand in the way, which have become a bulwark of shallow conceptions and cultivated opinions, upheld by exotic theories of science epicycles with no real evidence, fundamentally. It appears that we will need to heal science itself first, before we will consider the needed answers truthfully. If we remain stuck in the current trap of shallow concepts and science epicycles, a child may ask in future years as it grows up, "Dad, why do you want to kill us children by not building a world for us that we can live in when the sun goes dim?" "My child," a father might answer then, "don't be alarmed. The sun will not go dim." "But you don't know this for certain," the child might reply to such an argument after it grew up enough to think for itself. You cannot say with certainty that the sun will not go dim, because all the evidence points against your argument, indicating that the sun will go dim indeed. And when it does, what happens then? What will happen to us all when you are wrong? What would a parent answer to that? A father might say, "My child, nobody believes the evidence that you speak of to be what it appears to be." "Oh, is this so?" the child may answer years later, when the argument would come up again, and still nothing was done to prepare for the transition in the world that is to come. I should say the same to you, Dad, about all your fancy theories that you cling to explain the impossible that isn't really happening, which you don't even pretend to have supporting physical evidence for, such as the theories of electron degeneracy and the tunneling effect that you need to justify the internal fusion sun theory, not to mention the dark energy theorem that you precariously uphold to justify the dark umbra of the sunspots, and other exotic theories like them, such as the density wave theory that tells you what you observe with a telescope when you look at the galaxies doesn't really exist. What could a dad say to that, if in later years he would face a grown woman speaking of justice? Would he really believe in dark energy and the like, and brush away his responsibility to be truthful as easily as he did when he spoke with a child? Or would he begin to wonder if the sunspots are dark because there is simply nothing behind the shining facade, beneath the sunspots, as he suspected, instead of the powerful nuclear fusion furnace that supposedly heats the sun from the inside, but for which no evidence is shown? Nor would he be able to explain to an adult why the sun is far too light to be an atomic gas sphere of its size. "Oh, we don't have all the answers," he might say to his grown daughter uneasily. "We can only go with what we know." "That's a bad excuse, Dad," the adult daughter would say. "You didn't get off your high chair and made it your business to know the truth. If you had done this and had acted responsibly, and even if we had erred on the side of caution so that the Ice Age transition would never materialize, that you would have upgraded the world for, then nothing would have been lost, regardless. We would have gained a richer world then than we ever have dreamed of. Instead, you remained glued to your damn chair and did nothing. Whatever was uncertain before compares as nothing now with the certainty that we will all starve to death when the sun goes dim, by which our agriculture fails, that we depend on for our food. With this said, how much time do we still have left at this late date to build the infrastructures we need to save our existence? Probably too little. You have squandered too much of the precious opportunity we once had. Oh, if you had only listened when I first raised the question to you, Dad, a long time ago as a little girl, says the grown-up daughter. It all seemed is like a dream then, where nothing is real, and to you it all seemed academic in nature. I relied on you to tell me the truth, but you never did. You didn't have a good answer then, and never had, but you were not honest enough with yourself and with me to say so. For this dishonesty, you have committed us all to death, as have all the men and women whom you have failed to inspire with the truth. You have led the whole world to death, together with us, when the sun goes dim, by doing nothing towards giving us a chance to have a future. Fortunately, we are not at this point yet, where such a conversation would unfold, where we would be condemned by our children. We still have a chance to avoid the condemnation and treasure and protect what we have in each other. In order that a conversation as the one illustrated here may never take place, I am presenting a summary of the physical evidence at hand, which a child might use in future years to indict us, if we let it come to that. I am presenting a wide scene of evidence divided into 3 categories. 1. Our Sun as an electric fusion plasma star. 2. Our Sun being variable and vulnerable. 3. The solar cutoff timing. Number 1. Our Sun being an electric fusion plasma star. The list here shows just a few points on this theme. The plain evidence is that the Sun is dark inside, comparatively, when it is seen through the umbra of the sunspots. It is dark there, below the surface of the photosphere, because there is nothing there to be seen, with the Sun being a plasma star. The Sun is a plasma star because it is impossible for a gas sphere of the size of the Sun to exist. In a plasma sphere, no such problems can exist. Its mass density is determined by electric repulsion instead of gravity. Nor is it possible for the Sun to operate a nuclear fusion process at its core, where hydrogen atoms are said to be fused into helium atoms. The fusion process would blow the Sun out. The core would become clogged with the fusion product that dilutes the fusion fuel, by which the reaction stops. On Earth, the most advanced nuclear fusion reactor, the joint European tokamak, blows itself out after a burn time of slightly less than a single second, for this very reason. The Sun can't operate on this platform. The Sun can only operate as a plasma sphere with electric nuclear fusion occurring on its surface, from where the fusion products are carried away with the solar winds. That the Sun is powered by effective nuclear fusion occurring on its surface, in which all elements in the periodic table are synthesized, is evident by the unique distribution patterns of the elements across the planets. All the inner planets are made up of heavy elements for this reason, which are the first to be attracted out of the solar winds, while hydrogen, the lightest of the elements, gets carried as far away as Pluto. This wouldn't happen if the Sun was not the central synthesizing source for all the elements, which it is, since all the basic elements have been detected in the solar atmosphere. That the Sun is an electric star is further evident by the existence of the solar wind that is accelerated away from the Sun to speeds of 800 kilometers per second. What we see here is the natural byproduct of the dynamics that enable electric nuclear fusion to occur. If the Sun was internally powered, solar winds would not occur. The superheated corona, at hundreds of times the surface temperature of the Sun, would likewise not occur if the Sun was heated from within. The superhot corona is possible and natural only for a Sun that has a large sphere of highly condensed plasma focused around it by its primer fields. No magic is involved here. Number 2. The Sun is a variable, vulnerable star. The evidence is plain. Ice ages would not be possible if the Sun was an invariable constant in the climate theater. We would never have ice ages. Still, we have them. Ample evidence exists that ice ages have occurred almost for as long as humanity has existed, spanning more than 2 million years. No actual theory exists for the known ice ages to have occurred under a constant Sun, which renders the ice ages that we have records of to be the phenomena of a Sun going inactive, from which ice ages result. The Dansgaard-Oeschger oscillations that have occurred all the way through the last ice age, which we have ice core records of from 2 sites in Greenland, are not possible under a constant Sun, but are the natural result of the Sun being inactive all the way through the last ice age, with the exception of 25 brief occurrences when the Sun became active for a few decades at intervals of typically 1470 years, and then cooled down again. These enormous rapid oscillations between deep glacial conditions and near interglacial conditions are only possible with the Sun oscillating between its active and inactive states, with the inactive state having been the normal state for our Sun for 85% of the last 2 million years. In this context, the Dansgaard-Oeschger oscillations render our currently continuously active Sun a relatively rare anomaly that is about to end. That the Sun is not alone in assuming an inactive state may be evident in the existence of a large number of white dwarf stars. This is the type of star that one would expect to see for our Sun after it goes inactive for long periods, where it remains aglow only by slow nuclear decay of synthesized atomic material that the Sun had retained with its gravity from its active times, which slowly drift into the interior to be crushed there by the gravitational and electric forces in its core. During the initial Ice Age transition, as 120,000 years ago, towards a white dwarf state, our Sun may have gone through several intermediate stages, such as the so-called red dwarf state. We really don't know what precisely the sequences would have been. The last Ice Age transition from an interglacial period had occurred 120,000 years ago. No records were kept. nor do we really know what the type of huge transition means that is indicated here when the global climate suddenly gets 40 times colder than the little ice age in the 1600s had been, which is barely remembered, but is the only reference that we have available for comparison. Archaeological evidence speaks of severely depressed living conditions occurring all the way through the ice ages. The conditions were evidently so harsh that at the end of the last ice age, the entire world population had shrunk to a mere 1 to 10 million people. This was the end result, at the time, of more than 2 million years of human development. The minuscule population level, following the glaciation period, speaks volumes about the harsh conditions that evidently existed in our world under a mostly inactive sun, which we call the ice ages for the resulting effects. The deep population depression adds one more item of proof that our sun can and will go inactive, and has done so in the past. Another item of evidence for the sun being mostly inactive during the ice ages is found in the form of dust accumulation in the ice of Antarctica, shown in red here. The dust accumulations typically begin halfway through the glaciation periods and extend to the start of the next interglacial period. This type of phenomenon is natural for the resulting condition when the primal fields for the sun, which normally stabilize the orbits of the planets, cease to exist for long periods in which the sun remains inactive. Under such default conditions, or inactive conditions, the orbits of the asteroids in the asteroid belts and in the Earth's space invariably begin to decay. They become disorganized. Asteroids have a large surface-to-mass ratio and are more readily slowed by external influences. Eventually they begin to bombard the atmosphere of the Earth, where they disintegrate into dust. The asteroid intrusion has spanned in previous times more than 40,000 years. In each case, it stopped abruptly when the interglacial period began and the orbits became regulated again. Number 3. The solar cutoff is near. NASA's Ulysses spacecraft saw an amazing decline of the solar wind pressure by 30% over the span of a decade. It saw a new trend unfolding that is still continuing. If the trend is projected forward in a linear manner, the solar wind will diminish to zero in the 2030s time frame. Since the solar wind is a byproduct of the regulating system that keeps the sun at a relatively constant level, the solar wind cutoff point would mark the beginning of the weakening of the sun's energy production. The linear continuing of the weakening trend thereafter would likely lead to the collapse of the primal fields in the 2050s time frame. Coincident with the measured weakening of the solar wind pressure, the Ulysses spacecraft had also measured a 30% reduction of the strength of the sun's underlying magnetic field and a 20% increase of galactic cosmic ray flux penetrating the barrier provided by the solar heliosphere that weakens with the weaker solar wind pressure. The weakening has become evident all over the world in the form of a wide variety of meteorological effects. Increased cloudiness is one such effect. The increased white surface reflects more of the solar radiation back into space, which becomes lost to the heat budget on Earth, with cooling effects in the higher regions of the troposphere. The cloud experiment at the European Organization for Nuclear Research, one of the world's largest and most respected centers for scientific research, has demonstrated in principle that cosmic ray interaction with the atmosphere is enormously effective in increasing cloud nucleation. The measured effect went straight up and off the chart. The resulting colder temperature reduces the distance of the water transport by the clouds, which results in increased drought conditions and loss of agriculture. The increased cloud nucleation, of course, reduces the water vapor density, which is the main contributor to the moderating greenhouse effect of the atmosphere, up to 97% of it. With the moderating effect diminishing, we experience larger differences in temperature fluctuations, including colder winters, hotter summers, and ironically also Arctic warming during the Arctic summers as the result of the diminished moderating greenhouse. All of these effects are already experienced worldwide, while the continuing trend of the electric weakening of the solar dynamics will cause these experienced fringe effects to become increasingly more severe over the next 30 years. The continued weakening of the plasma system that is powering our Sun is also directly measurable on the surface of the Earth. It is measured in the form of the reduced deflection of the Earth's magnetic field. Without external influences, the Earth's magnetic field would be aligned with its spin axis, shown in red here. With strong external influences, the magnetic poles become shifted away from the geographic poles, shown in white here, by 23 degrees according to the inclination of the spin axis. With the external influence rapidly diminishing, the magnetic pole is drifting back towards its normal spin axis orientation. While other factors are involved in the observed phenomenon, the indicated pattern seems to suggest the electric weakening of the solar dynamics system is accelerating instead of remaining linear. The magnetic pole drift is even more ominous when one considers that the Earth's magnetic field itself is weakening, and it is said to be at its weakest state since records were kept. The effects of the diminished electric solar dynamics are not limited to the Earth alone, but are also evident on the planets. One observed effect is the shrinking of the great red spot on Jupiter, that became visibly smaller since the weakening trend began. Another item of evidence that a major weakening trend is in progress is evident in the solar flare index that is becoming noticeably weaker since the weakening of the electric solar dynamics began. Even the sunspots themselves are getting gradually weaker. The huge spots that blow out massive amounts of internal pressure are getting fewer, while smaller spots result that tend to be surrounded by a sea of little spots. It is impossible, of course, to forecast the exact time when the fragile solar dynamics system goes inactive, nor is it necessary. We know the trends, We understand the principles involved. We know the consequences. And we know what to do to reorganize our world to be able to live with the consequences. But will we do it? Sure, it is far easier to remain asleep in our chair with the comfortable illusion that the world will grind on forever, as it has since civilization began, especially so as the illusions are supported by scientific assumptions that would make us believe that nothing needs to be done, as the world will grind on forever. It is this comfortable indifference based on illusions, for which no real physical evidence exists, that renders the current Ice Age challenge the greatest science challenge of our time. The science challenge is not located in developing the physical means for building the infrastructures for the continued existence of humanity in an Ice Age world. The physical solutions are not difficult to implement in principle, with automated industrial production. But will we do it? The challenge to science is to get itself and humanity out of the easy chair, and this in time before the next Ice Age transition begins with the sun going inactive. We have the materials, the technologies, and energy resources on hand to build what needs to be built to assure our continued food supply. But will we use these resources? This question makes the science challenge also an intimate challenge to ourselves that challenges our attitude towards our children. It is tempting to stay glued to the chair and to say that the challenge is not ours, that it is in the court of future generations, thousands of years distant. However, the evidence seems to indicate that we are that future generation, so that the ball is in our court. In fact, we should celebrate that the ball is in our court, because we need the science breakout to what is real, because we are fast running out of energy resources, while ignoring the anti-entropic energy resources that we have within the electrically powered universe and solar system. The development of our civilization has been relatively short, spanning roughly 6,000 years. In the last 200 years of it, we began the large-scale energy use. During this brief span, our entropic energy resources have already been largely depleted. Some say we have only 60 years of oil left at the current rate of consumption, and we may have 400 years of nuclear energy left. What then? On the larger scene, with ice ages lasting for 90,000 years, it does not really matter whether we run out of oil in 60 years or in 1,000 years. We need an anti-entropic energy resource to have an endless future. We have no real option left, even now, except to develop the cosmic electric energy resources that can never be depleted, which promise to be sufficient to meet our relatively minuscule new human needs for all times to come, even in the solar inactive times, when the interstellar plasma streams have a wider focus. The science challenge definitely includes to get us moving into the cosmic energy direction as well. The cosmic energy development and the Ice Age infrastructure development are both elements of a single global science challenge that no nation on the planet is exempted from. On this platform, the challenge will be met as one of the most urgent common needs of all mankind, by which we stand united as one people of a single universal humanity. The summary in this video, as I said in the beginning, covers a wide scene. It opens the view to a grand adventure of discoveries. This means that the adventure has just begun, as the continuing exploration focuses on many details of the wide scene that is without end.